Today's lesson is on piecewise functions. We're going to recall that the absolute value function is an example of a piecewise function because if you look at piecewise functions, they are defined in a unique manner in that they're split up in what the value or what the function is for different parts of the domain. So for x values that are greater than or equal to 0, f of x equals x, and for values of x that are less than 0, f of x equals negative x. So you can see that you don't have just one statement for the function, you have two of them for two different parts of the domain. So that's why you have this V-shaped graph where f of x equals negative x for values of x less than 0 and positive x for values of x that are greater than or equal to 0. So by definition, a piecewise function is a function defined by using two or more rules over two or more intervals. As a result, the graph is made up of two or more pieces of similar or different functions. So going to this example of the absolute value function, which we just looked at, you can see that there are two rules here, and there's two intervals for one for each of those rules. So therefore, you have two pieces of your graph. They're connected at 0. It is continuous because there are no breaks in this function, in this graph, but there could be piecewise functions where there are breaks or discontinuities, and we will be looking at that shortly. So let's take an example. Suppose you were given that the parking at the airport is $5 for the first 2 hours, $5 flat fee, and $3 for each additional hour up to 16 hours, and $47 maximum daily. So you can see right away that it's not a one rate for throughout the day. It's broken up into three parts based on how many hours you are parked. So if you were to find the equation for this piecewise function graph, it's going to be divided into three parts because they're all different. So how do we go about finding out the equation for each of those and then graphing them? So let's break it up into the three parts and see each part separately. So for the first part, you notice that for the first 2 hours, that's from 0 to 2 hours. Now it doesn't include 0 because if you this is going to be, it does not include 0 but includes the 2. It includes the 2. Okay. Because if you haven't parked at all, you're not going to pay anything, right? So for 0 to 2, not including the 0, you pay $5. So it's a flat fee. And for the second part, which is for between 2 hours and up to 16 hours. So because it includes 2 up there, here your x, which is the number of hours, is going to be greater than 2 but less than or equal to 16. So between 2 and 16, not including 2 but including the 16, it's going to be $5 flat fee plus $3 for each additional hour. So that would be y equals 5 plus 3x, if you think of it as the equation of a line where you have flat, fee of 5 and the slope of the line is 3. But then again, this does not start at the origin. So we can't say 5 plus 3x because this value starts at 2. So what you need to do is you need to take this equation and shift it 2 units to the right. So then it becomes y equals 5 plus 3 times x minus 2. And that would be 5 plus 3x minus 6, or y equals 3x minus 1. That's one way to get the equation of that part of the line. A second way to get the equation of the line is to start with, so that's one method. Another method too would be, you have the y equals 5 plus 3x, but this is not going to work for this portion because it's only starting at the value of 2. It doesn't start at 0 like it would for a regular line. So add x equals 2, the y value is 5, we know that. Let's say another value of x, let's say at 3 hours, then you would pay 5 plus 3, which is $8. So you have 2 points here on this line, 2 comma 5 and 3 comma 8. So using those 2 points, you can definitely find the equation of that line, all right, that satisfies these 2 points. So the slope of the line would be y2 minus y1 over x2 minus x1. So it's 8 minus 5 over 3 minus 2, which is 3. And then the equation of your line becomes y equals 3x plus b. You can substitute a point on the line to get the value of b. Let us substitute the point 3 comma 8. So 8 equals 3 times 3 plus b. B equals 8 minus 9, which is negative 1. So therefore the equation of the line is y equals 3x minus 1. So you got the same equation here after doing all this work, or you could do it using this first method where we just start with what the equation of the line look like if it was starting at the origin, and if the the y-intercept was 5, but then shift it 2 units to the right because it starts at 2. Okay, so you could choose any one of these methods to find the equation for that half. And then we have a third part, which is the flat rate at after 16 hours. So between 16, but not including 16, and up to 24 hours, you're going to pay a flat rate of $47. Okay, so how would you explain this or write that as a statement? So f of x is 3 parts, so you'd say it's equal to, open up this big curly bracket, and you'd say 5 for values of x that are between 0 and 2, not including 0, but including 2. And then it's the equation of that line we just got, 3x minus 1 for values of x between 2 and 16, not including 2, but including 16. And it's going to have a flat rate of $47 for values of x between 16 and 24, includes 24 but does not include 16. And this is how you'd write the statement for the 3 parts of the function. So it has 3 parts and 3 intervals. You're also asked in this question to find the equation and its graph. So we need to graph this function, and I'm going to take out this part over here and look at the equation, the graph of the function. Okay. Okay, let's do that over here. So from x equals to this is 5, so it has doesn't include, we have a straight line up to 2, and then from 2 to 16 you know what, I'm going to have to, let's just draw it so we have more room to graph this. So let's say it starts over here. Okay, so we have that covered. Let's say this is our 5. So it's going to be straight line till there, and then it's 3x minus 1. So we have this point 2, 5, and 3, 8. Let's say this is our 8. We have 3 and 8. We have this point here, and we have a line. And then it is a flat rate of 47. Let's say this is 47. And so this goes up to 16, by the way. So at x equals 16, you have 3 times 16 minus 1, which is 47. So let's say this is our value at 47. It makes it easier to just join this using a line from here to here. Okay, so it's not going to work. We just have to draw it by hand, but you get the idea. You want to use a ruler for this. I'm not able to use the tool, so I'm going to just connect dots here to show you that it's going to be a straight line. That is your 3x minus 1. And then you're going to have a flat rate from 47 onwards. So it's going to be a straight line like that. So you want to take a ruler and connect the dots so you have a straight line from here to here, and then a straight line from here to here. And it's a continuous function, as you can see. It has 3 parts, so a flat rate of 5, and then 3x minus 1, and then $47. Okay, so you want to draw that to scale on graph paper, not like how I've done. You want to do it on actual graph paper. Okay, and the second question you have here, parking at the airport, $5 for the first hour, 12.5 for the each additional hour up to and including 2 hours, and a flat rate of $13 plus $3 for each hour after 2 hours. Find the equation and the graph. So again, in this function, you're going to find that you have 3 parts, right? You have the 5. So what does it look like in the function? The function would be between 0 hours and 1 hour, not including 0, but including the 1. You have the $5 flat fee. Then a flat fee of $12.5 for each additional hours up to 2 hours. So including 2 hours, not including 1, so greater than 1, less than or equal to 2, $12.5. And then a flat rate of $13 plus 3 times x after 2 hours. So x minus 2 for between 2 and it actually doesn't say it for the daily maximums. That means that any hour after the 2 hours is going to go with this. So there's no limit on upper bound on this. So we are going to say for any x value that's greater than 2, then it's going to go with this rate. Okay, and you're going to have to draw the graph so that you have 3 parts to it. You have the so one part is where it's 5, and then it's flat for 12.5, and then it starts to go into a straight line. So this one would be 13 minus 6 plus 3x, so it would be 3x plus 7. Right? So for 0 to 1 hours, so this is our x and this is our y, or f of x. So 0 to 1, you have 5. And then from 1 to 2 hours, you have 12 and a half. And here, when you draw the graph, you have to show that 1 is, it's a complete circle there. Whereas here, you have an open circle because it doesn't include the value at 1 hour will go with this rate, but not this 12 and a half. Okay, and then any value over 1, it would be 12 and a half. And then over 2 hours, you have the line with the slope 3x minus 7. So I'm not having a graph here, but on graph paper, you want to do this so that you have a line with that slope. And so it's going to go from here, you're going to draw a line with that slope, with its slope being equal to 3 and its y-intercept will be 7. And that will just continue because that's a fixed, that's a rate that's going to go for any hour over 2 hours. Here you have two piecewise functions. Let's do the first one. F of x equals square root of negative x for all values of x less than 0. It's equal to negative x between 0 and 5, includes 0 but not the 5, and is a flat value of negative 6 for all values of x including 5 and above. So you can see here that there is the square root function, and then there's the equation of a line with a negative slope, and then there's the equation of a horizontal line, negative 6, right? So there's 3 parts to it. So you want, on graph paper, you want to plot the points at first. So if you have, let's say you have a x and y axes like this, and this is the part of the graph where you have the square root function. It's when your function is root of negative x, that's a vertical, a horizontal reflection, so it's a reflection in the y-axis. So typically the squared function is like this. So if you reflect in the y-axis, it'll open this way. So you have this half for all values of x that are less than 0. And then from 0 to 5, you have a straight line, and so you get the points there. And then for all values of 5 over 5, it's negative 6. So here you have an open circle because it doesn't include 5. And then let's say this is your negative 6, and you have a straight line from negative 6 onwards. It includes the 5. So this is your 5 hours, or 5 whatever that mean represents. It doesn't really have to be hours. We're not looking at a parking question right now, but at 5 hours, you'd go with negative 6, and anything after 5, it's going to stay at negative 6. But from 0 to negative 5, you have a straight line. Now, it doesn't look like a straight line here because I'm not able to draw it with this tool. It's not working for me right now. But you want to use a straight line to show that this is y equals negative x, and this part is a squared function, this part is a horizontal line. Okay, and then you have the second example here, which is again having 2 parts. So you have 1 over x for x less than or equal to less than 2, and x squared for greater than or equal to 2. So how would you graph that? So let's say, how does the reciprocal function look? So you're going to have a function that looks, like that and like that, right? But now at x equals 2, there is a break. So you're going to stop at x equals 2, and it's going to be x squared. So at x equals 2, g of x equals 2 squared, which is 4. So at x equals 2, now the value is 4, right? And then from then onwards, you have the quadratic function x squared. So here, So in this one, where do you put the hole in the graph? You will have an open circle here and a closed circle here to show that there is, at any value of x that is less than 2 but does not include it, you would use this part, this function, the reciprocal function. But in including 2 and above 2, you would go with the quadratic. So you can show those two functions like this. I've shown it over here. You can see that for this f of x, there's no breaks in the graph because those values are continuous, except over here when it becomes at x equals 5. Then you have to show that at 5, this is the value you would take. Anything over 5, you would go with this line. Similarly here, you can see that there's a hole here and there is a discontinuity. And so after, if you wanted to find the value at 2, you would go with this. But anything less than 2, you'd go with this part of the function. And then that's a quadratic after that. Create an algebraic model for the function described in this graph. So you can see that there's two parts. One part of the function is for x values. This is 1, 2. So for values of x that are less than or equal to 2. So this is the part of the function for x less than or equal to 2. And this is the part of the function for values of x greater than 2, because this value is 2 here. So you're going to have, this is a line, looks like a line, but we need to find the equation of this line. Let's find its slope and y-intercept. If we look over here, we can see that the y-intercept is the b value, or the y-intercept is -1. And we can take 2 points in the line and find its slope, or we can do rise over run. We can see that the slope of this line is -1/2. So for the first part, the equation of the line is y equals -1/2 x minus 1. And then let's find the equation of this quadratic looking curve here. So this point here, by the way, we can just write that as 2 and -2. And this point here is 2 and +2. So the vertex of this parabola is 2, 2. So we can say that for the second part, for x greater than 2, the equation of the parabola is y equals, in vertex form, ax minus h squared plus k. We can write the vertex y equals ax minus 2 squared plus 2. And to find the a value, we can substitute a point on this line. Let's substitute another point, let's say at x equals 4. The y value is 6, so we have a point here, 4, 6. Let's substitute 4, 6 and find the a value. 6 equals a 4 minus 2 squared plus 2. 6 equals a times 4. Because 4 minus 2 is 2, 2 squared is 4, plus 2. So 4a equals 6 minus 2, which is 4, a equals 1. So we have the equation of the parabola as y equals 1 x minus 2 squared plus 2. So now that we have the equations of both parts of this piecewise function, we can write the statement of the function. We can say f of x equals, open brackets here, big one, -half x minus 1 for x less than or equal to 2. It includes 2, so you can see it's a closed circle here. And then it is x minus 2 squared plus 2 for all values of x greater than 2. I'll write that a little more clearly there. X greater than 2. A piecewise function can either be continuous or not. If all the pieces of the function join together at the endpoints of the intervals, then the function is continuous. Otherwise, it is discontinuous and at these values of the domain. So I have here 2 examples shown. The first one here, you can see it's continuous because there's no holes or breaks in the graph. So you have here f of x equals absolute value of x for all values of x less than 1. I've written that here. And it's the square root function for values of x greater than or equal to 1. Okay. Whereas for this function, you can see that up until 1 and including 1, it follows this parabolic function. And then for values greater than 1, it's a straight line. So to write the function, you need to find points on this function and find the equation. So for this parabola, you can see that we took this point 0, -2, and you can find that's the vertex is 0, -2, and then you can use another point and come up with the equation of the parabola. So that's the equation of the parabola. And then again for this line, find 2 points in the line, find the slope, use the slope formula, and substitute one of the points, and you will get the equation of the line as x + 1. And you write that, but be careful to also know where you have the open circle and where the closed circle happens. Okay. And here we have an example. Determine if the function is continuous or not over its domain, and graph it to check your answer. So you have 3 parts to this function. 2 times square root of -x for x less than 0. And then sine x for x between 0 and 390, including 0. And x minus 400 squared, so that's a parabola, for x greater than or equal to 390. So we need to find out if there's any breaks in this graph or not. So let's just check that. Let's check at what happens at those points where the function changes. So we're interested in looking at what happens at 0, because that's where the shift happens. And then the next is at 390, because those are when the function changes. So at x equals 0, right? Let's take values of x that are less than 0. So let's show it as f of 0 minus. So what happens? What's the function's value for values of x less than 0? It would be f of x would take on 2 times square root of -0. 0 is neither positive nor negative. So it's 2 times 0, which is 0. And for values of x that are, to the right of 0, which is 0 plus, your at that 0, your function is sine of 0, which is 0. So you can see that at 0, regardless of whether you go with this function or this function, the value of the function is 0. So there's no breaks there. And the second thing we need to check is what happens at x equals 390. So at x equals 390, let's see what happens to the 2 functions. Let us find f of 390 at both of those functions. Okay, so the first one is sine of 390. Sine of 390 is, if you do that in your calculator, it's 1/2. And let's see what happens to the function for the quadratic function at 390. So f of 390 in that case is going to be a negative of 390 minus 400 squared. That's negative of 10 squared, which is negative 100. So you can see these values here are not the same. So there's obviously going to be a break in the graph at 390, because as it shifts from the sine function to the quadratic function, the values are not the same. So therefore, the graph is discontinuous at x equals 90. So therefore, the function is not continuous, or has a discontinuity at x equals 390, but it's continuous at x equals 0. Okay. And then if you want to show the graph of the function, you want to have, take it on graph paper, plot some values for graphing the square root of -x, and then the function from 0 to 390, and then a few values of the quadratic after 390. And then you can see here that there is a break in the function. So you want to show that this is open here because it doesn't include it, and then it's closed here because it includes this. Now you can practice the assigned questions.